Constructive Voices, the podcast for the construction people, with news, views, and expert interviews.
Hello, I'm Steve Randall, and welcome to Constructive Voices as we continue our focus on climate change, sustainability, and biodiversity. In this episode, we're talking about heating solutions.
It's just got to be like a pragmatic, sensible approach of looking at what can we do, what's available now, and then how we implement it. Going fully electric or going fully hydrogen, it's not practical and not adoptable either.
That's Tom McGee from X-Heat. He'll be talking to Jackie de Burker in just a moment.
Constructive Voices media partner in Ireland and the United Kingdom is Construction Industry News. Since 2002, Construction Industry News has been focused on the very latest projects and developments within the UK and Ireland.
My name's Thomas McGee, and I'm the founder of X-Heat Limited, manufacturer of low-carbon heating systems aimed at the commercial and leisure heating industry.
Perfect. Now, Tom, I'm going to just delve right in because I know you're familiar with Constructive Voices and that we're very much exploring the issues of our time, the likes of biodiversity net gain and lots of things around sustainability within the built environment. According to the UN, energy and how we use it is at the heart of the climate challenge. Now, globally, humanity's energy use, it actually represents by far the largest source of greenhouse gas emissions. In fact, about 2/3 of global greenhouse gas emissions are linked to burning fossil fuels for energy that we then use for things like heating and electricity. So leading on, Tom, from that statement, can you do an elevator pitch about your company and its product range?
Yeah, so that's absolutely right. And whether many people are aware of that or not, I'm not too sure, but yeah, it's just over 2/3 of all greenhouse emissions are produced by space heating. So this could be in domestic or commercial properties. X-Heat is really focused on trying to solve this problem. And the way we are going around this is using an existing technology, but it has a slight difference to it than traditional combustion methods. So our technology is using a catalyst to oxidize gas to produce useful heat. And this heat can then be distributed into commercial, domestic or leisure facilities. And the benefits of using a catalyst versus traditional combustion methods are the elimination of NOx emissions, carbon monoxide, and around about a 90% reduction in CO2 emissions. This is really how X-Heat is trying to tackle this problem, knowing that it is a massive challenge for the UK to try and reduce its energy consumption, but at the same time still provide a livable environment.
So tell me something, Tom, like from a sort of a person who's not involved in the industry that you're involved in, and with your 15 years or so of experience working in the commercial and domestic gas industry. The first thing that sort of strikes me is, but we're still dealing with gas. Like, surely that's an issue.
Yeah, so the UK housing stock, or the UK, not just the housing stock, but all of our sort of commercial buildings as well, is being built upon or around using a gas network. And I guess it's got a bit of a dirty word lately, gas. People, do associate burning gas as being a dirty process. But again, what X-Heat's trying to do is educate people on that there's a different way of combusting gas, if you like, and that is by using a catalyst. I don't feel like the gas network that we're using, we don't need to get away from using gas. Not straight away. We don't essentially have to swap to using hydrogen either. Our focus is looking at making a change at the appliance in the property. And the reason for that is it's, to get off gas, it's going to take an awfully long time. We can't all go electric. The grid just doesn't allow us to do that, not anytime soon. And why sort of pigeonhole ourselves into just relying on one energy source when there is potential to still use gas, but use it in a much cleaner way?
That's interesting. So now you've explained it in a way that myself as a layperson, without your background, I do get it. And I know that there are, from our research together, there are some serious benefits in how you're producing, the products there at X-Heat. Would you like to run through those, Tom?
Yeah, so the two main products that we're working on are a commercial space heater and a outdoor patio heater. These two products are pretty big polluters in the industry. So commercial properties, take a lot of energy to heat up. That causes a lot of exhaust emissions, gas emissions. And also the outdoor heating industry. I don't know if you're familiar, but some years ago they were talking of banning propane patio heaters because of the CO2 emissions that are produced by these appliances. And in that industry, since we've had COVID, there's been a massive push for everybody to get outdoors, especially in the sort of restaurant industry. But the UK climate doesn't really sort of cater for an outdoor experience, once you get the other side of the sort of summer season. So, yeah, we're developing products for these two areas. It's using an existing technology which has been tried and tested and can reduce CO2 emissions by up to 90%. It can run on the existing gas network. And we're super excited about getting these products to market.
Okay, fantastic. So give us a little bit of background, Tom, about yourself. What actually led you to set up X-Heat?
So, 15 years ago, walked into a business based in the Northeast, which was specialising in designing and installing industrial ovens. Now, at this time, I had no experience of working with gas. I'd just come out of an apprenticeship as a mechanic. Mm-hmm. So walked into this business, totally green, knew nothing about gas. And, got took on this journey of installing infrared catalytic heating systems in the industrial sector. And this was predominantly for drying paint, a very boring subject. But actually the way that we dry paint was actually really exciting. And as I started to get more involved in this business and then started to go to college to learn about gas and get my qualifications, I realised that the appliances I was working on were unheard of in college and with my other tutors and other peers. So this was maybe 10 years ago. So continued working and developing in this business, like personally developing and also learning about how to run a business and design products and, speak to customers and things like that. And then 5 years ago, there was a really big push towards, climate change, because before then, there wasn't a lot. There was the Carbon Trust was around, who was giving out sort of grants to businesses to do something about CO2, but there wasn't a lot of noise. It is really only in like this last 5 years where there's been a massive push and the government's incentivized businesses to do something. And so that was the time when I thought, right, I'm going to take this technology out to the mainstream and start pushing it and trying to educate people on that we don't actually have to get off gas just yet, or we just have to change the way that we use it. And so that's what led me to taking this existing technology that I'd come across in this business, setting up X-Heat and going on this sort of product development journey with this technology and trying to apply it to as many different areas as possible. And here we are now in 2023, and we've got our first product ready to launch.
Fantastic.
Into the market.
What actually strikes me, and it often strikes me with different guests that we've had on, is the background of a person is quite often fascinating in terms of you were trained or already trained up as a mechanic. So have you brought that, those learnings into what you're doing now with catalytic technology?
Yeah, it's a bit of a tongue twister, isn't it?
It is a bit.
It's the catalytic converter or the catalyst. Yeah, it's a tricky one to say, but all of the experiences that I've had, you have some days where things just pop up and you're like, oh god, that's real. I learned that skill, or I had that conversation with somebody back then. And in terms of product development, having that like sort of mechanical background has definitely helped. And I also did a distance learning course in mechanical engineering at the same time I was setting the business up, because I'd never developed a product ever. So I thought, let's go on another learning journey. So I've got that skill set under my belt now as well. And that's massively helped, because when you're developing a product, there's many different processes in terms of how you work the metal that you're going to use to build the product, whether it's CNC machining, laser profiling, all these different sort of processes that are out there. Yeah, there's a lot to take in. So yeah, all of the lessons that I've had along the way have definitely helped me to get to where I'm at today.
Definitely.
But the main one is the people that I've been able to meet on this journey as well. They've been fundamental in supporting me and getting me to where I'm at.
Good, good. Well, listen, I mean, I can imagine sort of having that feeling that you're going to create a product and then what, So,
Yeah, well,
so obviously
that
you have to break it down, as you've said, between the mechanical engineering and all, understanding the different processes and so
the
on that go into, I'm going to say it properly this time, catalytic technology. What exactly is it for those of us who don't know, Tom?
I think it's one thing developing a product, but then trying to incorporate a product which nobody's heard of as well. You kind of, doubling down on your difficulty or complexity of trying to get this into the market. So essentially what a catalytic heater is, I mean, there's many different types of catalysts, but the one we use in particular is imagine a porous fiber pad. So this could be like the rock wool that you see in your house.
Mm-hmm.
So the insulation rock wool you see in your house, very similar to that, but it's got a wash coat of precious metals. And what happens is when you introduce a hydrocarbon fuel across this pad or through this pad, it reacts with the precious metals. It's called an oxidization process, and it breaks down the gas, and the reaction that takes place generates a heat. And this heat is in the form of a medium to long wave infrared energy. Traditional combustion systems or heating systems where you have a spark igniter and a flame, we don't have any of them components on our products. We are just relying on that oxidization process to take place every time, which it does. There's very little degradation to the catalyst over time, and it's a very uniform and consistent heat output. It's been around for about 75 years. It's been around for a long time, but for whatever reason, does not being adopted in the commercial or domestic or leisure industry. Predominantly, it's being used in the offshore gas industry, and the reason for that is you have very volatile atmospheres in that sort of environment, so they still have heat requirements, but the last thing you want in that sort of environment is a spark or a flame.
Sure, yeah.
So that's where the catalyst really comes into its own, because it's classed as intrinsically safe. And that's where I was working and sort of put the two together and thought, well, the offshore industry for like process and drying paint is so small, you can't really have a very big impact on carbon emissions. You've got to be focusing on the commercial, domestic and leisure industry. They're the biggest contributors towards carbon emissions. So I just looked at this technology, thought, wow, it's a very cool piece of technology. It's great for the environment in terms of it lowers emissions. Why is this not being adopted elsewhere? And so,
that is amazing. That is amazing. I mean, I'm hearing what you're saying. Why do you think it wasn't adopted? With it being available for so long.
I really don't know. I mean, that's why I did something about it. Because it's a little bit like the heat pump. The heat pump's been around for 50 years.
Yeah,
it's
sure.
only like the last 2 years that everybody's saying, oh, we should use heat pumps. And it's just, well, why have we not been using heat pumps? I really don't know. It's
I guess convenience, probably, like a lot of things. No, it's just
convenience, or I mean, the industry, the way it's set up, it's got some very big players involved in it. So whether it's a sort of a monopoly on that and that sort of the one thing I've seen happen in the last couple of years with the sort of push towards climate change is the doors have opened up now for new people to come in.
Sure.
We're in such a hurry to try and solve this problem that the energy sector it can't do it by itself. It's had to rely on other people getting involved. And we work with quite a few of the universities locally, and some of the projects they have in their labs focusing on this problem with heating and cooling. There's all sorts of technologies being discovered or reinvented. But I don't think that was happening maybe 5-10 years ago or even longer.
It probably makes sense, Tom. Obviously, things are, as us humans have spent such a long time not being aware or not having the motivation to be aware of what we've been doing to the environment, obviously to the earth and so on. So now that the awareness has been raised, it's like there's kind of a rush now for people to be heroes and heroines, I think.
Exactly, that's right. So, and that's what this sort of journey is all about, isn't it? It's about opening doors for new ideas to come in and new innovation. So it's a really exciting time to be involved in the energy sector. I don't think there's ever been another time like it, where we have this target of 2050. God knows what happens in 2050. But we have this target in 2050 that we've got to reach, and it's going to take a full-on effort from everybody. As I think your last guest mentioned, Ben Stansfield, he mentioned,
Sure.
We have all of these targets: 2025, 2035, and 2050. But there's actually stuff we can just be doing today, every day. Everyone could be doing it, sort of helping towards this target of net zero by 2050.
It's for everybody. That's the thing. It's not just for those in, positions of power or the energy companies or
That's
specifically the built environment or agriculture, all the obvious sectors. What do you think, just going back to X-Heat, what do you think differentiates what you're doing from any potential competitors? Are there not other competitors trying to do something similar now that it's so open up, as you say, what you've observed within the universities nearby you and so on? What makes you different?
So I say, X-Heat does heat differently in the fact that we use catalytic combustion rather than traditional combustion. From the research I've done, there isn't anybody else applying this technology into the areas we're looking at. And again, why that is, I'm not too sure. But one of the biggest barriers we had to overcome was sort of around the certification process. So there's obviously strict regulations that need to be adhered to when you're building and releasing a gas appliance into the industry. Obviously, for one, you've got to make sure it's safe. So whether that's been a barrier to adoption for other companies to do, because it's, that's what we've had to use the investment for, is to get us across that hurdle, which, it's not just a money thing. It's, you need good engineers who have been through that sort of process before. So whether that's been a barrier to adoption. But what makes us different is just the way that we use the existing gas infrastructure and that we can achieve these reductions in emissions and still provide useful heat.
Tom, just very fascinated about the technology itself. And what kind of settings are you currently using nanoheat in?
Yeah, so nanoheat is being developed to provide space heat in a variety of different settings. So this can range from anywhere from distribution warehousing, it can be construction sites, it can be industrial units, museums, automotive garages, essentially anywhere that's a sort of large industrial or commercial premises with people working inside of. 3 of the sites that we have converted already in the northeast fall under sort of manufacturing, welding and distribution. And the advantages of our system versus traditional heating systems are that the majority of our heat is focused on heating the person and not the air. And a lot of the buildings around the UK, these industrial and commercial buildings, are not very well insulated. So if you're using traditional heating methods, your primary heat source is heating the air, which generally rises and goes up through the roof space. So It's just, it's a massive waste of energy. So it's obviously, of late, it's costing companies a lot more to run these heating systems. And, sometimes 50% of that is just going up into the roof space. Lovely for the birds, the seagulls on the roof, keeping them warm. So our system can be used in any sort of large open space where there's people working. And the approach we tend to take is, ours is a lot more zonal. So we look to heat zones of the factory, because if you look at the floor plan of most of these factories, it's very rare that every single square meter of the factory is being used by an operator or an engineer. Generally, they're in sections or cells. So you'll have like goods in, you'll have quality control, you'll have welding bays, assembly. So if you look at the floor plan of a factory, it's generally little pockets of areas where people are working. So nanoheat is being designed to provide zonal heating. And this was very evident during the pandemic, where you had sort of split shifts. Not everybody could be in the factory at once. So you were sort of having to dissect your workforce up. But existing heating systems that are centralised, you were still having to heat your whole factory, even though you only had half your workforce in. Whereas with the nanoheat system, you could have modulated or zoned off sort of certain areas of your factory and provided just heat in them areas that the work was getting carried out in. So there's many benefits to using this system, and there's no sort of limitation on the sort of environment it can be put into. Like I say, it can even go into livestock sheds
One thing, Tom, you've a couple of different case studies on your website, and I've focused in on one just purely because of what they do. Yaskawa,
Yes.
UK Times. They're obviously working with artificial intelligence, industrial robotics, digital data. So, it's fascinating, obviously, the niche that they're in. Are they a big premises, and how exactly have you worked with
So
them?
they have a premises based in Newton Aycliffe. So it's around about it's about 200 square meters. And yeah, they build robotics for all sorts of various applications. And at this particular site is where they will build and test the robot before it gets shipped to site. So again, it's sort of very like zoned working. They have cells where they're carrying out different parts. It could be quality checking a certain part. It could be implementing that part. It could be writing software or code. And yeah, they were using. They had two types of heating system in there. Initially, they had a hot air blower. So this is a sort of ceiling suspended hot air blower around about 100 kilowatts, and then they had a small floor standing propane heater, which is basically just firing a naked flame into the working area.
Doesn't sound very healthy.
It's a health and safety officer's nightmare because you've got trailing cables, you've got loose propane bottles on the shop floor. You're essentially just blowing carbon monoxide into the workspace. We came along, looked at what their heating requirements were, and offered them a zonal heating system. So they went down from using probably around about 140 kilowatts of energy down to around 50 kilowatts. So massive energy saving. Again, the case studies on the website there for people to check out. But yeah, the energy savings and the return on investment on that sort of project was pretty incredible. And then just from the safety side, removing all of that carbon monoxide and nitrous oxide that was getting pumped into the factory, that's all gone now. So it's a lot sort of healthier and cleaner place for people to work. And the other one that people might not be aware of is the noise. The noise that comes from these floor standing hot air blowers, and even the ceiling suspended ones. They've got giant fans on the back, whizzing round, blowing the hot air out. You don't realise it when you're working in there because you just think it's just the noise. But it was only when we went to a nano heat system, which is pretty much silent, that you actually realised how noisy these other appliances are. So there was sort of like a really good case study for energy saving, but there's a really good case study for improving the well-being of the operators in terms of reducing noise pollution, reducing atmospheric pollution. So yeah, really successful job.
And what about the transmission of diseases? Surely it should be reducing, from what you're saying, it should be reducing the chances of diseases being spread.
It's definitely going to make the environment a lot warmer and safer to work in, yeah. And in terms of the emissions that are getting produced by these other types of heating system, yeah, that's obviously going to have an impact on your sort of immune system and well-being. Not that we didn't measure the sort of impact it's had on the well-being of the operators, but you can just tell from the data in terms of the emissions that are being put out, it's significantly safer and better to work in a nano heat system.
It would be interesting for some of your case studies to consider doing studies of their team and seeing, like, in the sense of sick leave and things like that. Of course, there's going to be some patterns that they could compare it to.
Yeah, no, that would, and I guess that's what we could measure over time is whether that is whether we have been able to reduce that sick leave, because then that's another return on investment for the customer. Keeping the staff at work safer and healthier just improves productivity. Now,
your company, X-Heat, Tom, is the first company, as far as you're aware at least, in the UK to achieve the prestigious GAR approval. Talk us through, first of all, what is that, and how come you seem to be the first company in the UK receiving it?
GAR is the Gas Appliance Regulation. So it used to be GAD, which is the Gas Appliance Directive. But in 2015, they changed the rules on who had to be GAR approved or GAD approved. Basically made it a lot more strict. It was for imports, so I think people were obviously importing gas appliances from in Europe and then selling them in the UK market. And I think, maybe the quality elsewhere wasn't as up to sort of the UK standard. So they brought this GAR approval in, which meant that even if you import gas appliances now, you still have to come under it. And there's some sort of scrutiny that has to take place on the appliance to make sure it's safe and meets UK requirements. When you introduce a new product to a customer, if they're unheard of it, the first question they always ask is it safe? So to achieve that GAR approval was critical to our business, to not only demonstrate how it can actually improve efficiency, improve the well-being of people, save you money, but also it actually meets all the safety standards as well. And yeah, as far as I'm aware, nobody else. I mean, this is at least the feedback we got from the regulator, is that there's no other company with this certification on this type of appliance, this particular application. So again, that sort of makes us a little bit stand out and novel. And really, again, I don't know why that is, but all I can say is it was very challenging, to say the least, to get this appliance through that sort of scrutiny. And that's because all of the regulations that have been created to check the safety and reliability of these gas appliances, it's all based around traditional combustion. So this is spark ignition, this is flame failure devices, or FSDs. All burner controls have been designed to work with spark and flame, but we don't have them two things in our application. So we had to take a bit of a hybrid approach, and the guys at BSI have had to work from. It's been challenging for them and challenging for us, but we've got there in the end. And now we have this GAR approval, which we can now give peace of mind to our customers that we meet the highest standard in gas certification.
Any of the case studies that you have on your website, or that you haven't as yet put on your website, Tom, do you have any actual hard figures in terms of financial savings, or is it too early days for that? Talking about the likes of, any of the factories that, industrial clients that you're working with?
So when we carried out these installations, these beta tests, we put gas meters on every single appliance so that we could measure and collect the data to prove that what they had before versus what they've got now was a significant reduction in energy consumption. So on them case studies, all of the figures that you'll see on them case studies is all being collected from actual gas meter readings. We've got some more content coming out very soon where I'll talk around reductions in gas that we've been able to achieve with taking out old traditional heating systems and putting in these new nano heat systems. So we've just come up to our first year of where these systems have been running. So we've just gathered that data, and we're just putting that into a format where we can upload it into sort of a video format and let people know that the gas savings are real.
Now, you're not working with any sort of domestic settings at the moment,
No,
are you?
We're not. This is.
Any reason for that?
Well, we have got ideas of working in that industry, and we are working on some things. But the two products that are closest to market are these commercial and leisure heating products. The domestic industry, we are doing something in that space, but it's still very early days yet. There's a lot more complexity in developing a product for that sector. Watch this space, I'll say.
Okay. Okay. Now, obviously, we're in, as you said earlier on, Tom, very exciting times, and a complete switch from traditional combustion to catalytic combustion across the gas network in the UK would, be absolutely central in achieving the net zero targets for 2050, also at a fraction of the cost. Now, you state on your website, as the heating industry evolves, X-Heat is primed to seamlessly adapt to emerging technologies, including the potential transition to hydrogen networks. That sounds fantastic, it sounds ambitious, but are there not safety concerns around this transition?
Is that a transition to a hydrogen network, or would that be a transition to a hydrogen network with catalysts?
Let's talk through the two possibilities and see, you as the expert, what is the better option, what's more achievable, given the fact that, of course, what's available to work with is old and probably, quite limiting in some ways.
Yeah, no, so that is the great point, is to achieve net zero by 2050. Are we saying that we need a hydrogen network to do that? Now, if we are, that's a major overhaul of the gas network. There's problems in there which we still don't have answers for. There's the cost of doing that we don't know yet. And the biggest one for me really is if we went to 100% hydrogen using the appliances that we have today. And again, this is research that's available on the internet from various universities. There's a correlation between combusting hydrogen, increasing the flame temperature, and increasing NOx emissions. So it would seem to me like a bit of a bad idea to combust hydrogen if it's going to increase NOx emissions. Now, it might lower CO2, but it was only 2015 where we hammered the automotive industry on NOx emissions because they were too high. So, yeah, it's I don't know, the hydrogen network's a bit of a strange one. Personally, I don't think it's going to solve the issue of by 2050. If we do go with it, who's going to pay for it? It's going to be massively expensive. We've got to produce the hydrogen. We've got to produce it cleanly. It's a lot of noise at the minute about hydrogen, but not a lot of action.
Okay. What would your sort of recommendation, if I was, sitting with you in a government scenario where decisions were being made, what would your combination, of various energy methods be, more or less in a percentage breakdown? How would it work in your vision with your expertise?
Well, I think we have to have multiple energy sources. I don't think we can become reliant just on one. So I'm definitely not just all for gas or hydrogen. I think this is probably one of the bad things that's come out of this push for net zero. Is there's a little bit of tribalism in some places, isn't there? I don't know if you've picked up on it, but you get the people who love the electrification, you get the people who love gas, and it just
solar, etc.
Exactly, and it's just like.
Yeah.
It's just not the approach to take.
There should be a combination, right?
It's a combination, exactly. Not every house can have a heat pump, but some houses can. Not every house can have solar, but some can. Depending on where you are in the sort of in the UK or even in the globe. So I think it's just got to be like a pragmatic, sensible approach of looking at what can we do, what's available now, and then how we implement it. So I think. Going fully electric or going fully hydrogen, it's not practical and not adoptable either.
Do you have any countries that you're aware of with all the research and all the creation that you've been doing with your work? Are there any countries in the world that you've sort of say that's quite a good role model? They're ahead. They're ahead of the UK, or is that not the case in your mind?
Well, I did see some data the other day, which is pretty fascinating. Is how many European countries are still burning coal? So I don't. Yeah, it's hard to say really what other countries are doing or implementing. So I'm mainly just focused on looking at what the UK is doing. So, but yeah, someone shared some data with me the other day about 3 of the European countries are still burning coal at a rate of the same amount of terawatts of coal being burnt as what the UK uses in all of its energy system. So that's pretty.
That's a shock, obviously. That's a shock.
Because again, this whole net zero thing, it's not just one country who has to do it. It's all of us. So I'm not fully aware of what everybody else is getting up to or what they're doing. But me personally, from what I have seen in the UK and what I've worked on, is this new adoption of this new combustion method could make a huge impact to the UK. And it could go further afield. It could go to Europe. And I believe it would be for a tenth of the cost, because we wouldn't have to renew the gas network. We wouldn't have to create the new gas. It's tried and tested. That's my sort of thoughts on that.
So how would that look, Tom, in terms of, like, again, going with your expertise, in terms of rolling it out? Is it a relatively fast process from what you've said? So less expensive and more speedy?
Yeah, so installation, it's around about 30% reduction in installation time. So this is because we don't have any exhaust flues. Because we don't produce carbon monoxide or nitrous oxide. traditional combustion systems, majority of them have flues. It's got to go outside the building. So that means you've got to do roofing work, you've got to drill holes. It's all, heavy, labour-intensive work. So installation times are reduced. The rollout of the product, you're relying on the existing gas infrastructure network. So this is the 110,000 gas-safe engineers we already have. They're there, ready to install this product. So yeah, the sort of steps to rolling it out are already here now, happening every day. It's the biggest barrier for us is just the educational side, and this is why I'm grateful for being able to get on this platform and speak about this. It's just making people aware that there's actually this other technology we could use to combust gas, and it's a lot cleaner and a lot more energy efficient. That's sort of our biggest barrier to getting this product rolled out. Everything else is already there, happening every day in terms of installation and servicing, maintenance, things like that.
So I think the number of guests that we talk to about these things that are, of the utmost important, various aspects of sustainability, net zero and biodiversity and all those topics is, unfortunately, whether we like it or not, money is still very central to these decisions. And I guess apart from, as you say, a lack of education about what you've created, I think that you probably have to speak to people's, purse strings or bank accounts. And I think that's probably one of your biggest selling points, apart from
absolutely.
What sort of savings, let's finish up on that. What are the percentage of savings financially that can be made?
So, so like what it says on our website, we can guarantee up to a 50% reduction in energy consumption. So to put a price on that, it would obviously depend on how much you pay per kilowatt. But again, if people get in touch, we can sort of work out what that cost saving would be based on the cost of the equipment. We can do a return on investment. There's government incentives. So at the minute, not everywhere, but certain regions, so like the Tees Valley is one, Greater Manchester, the Northwest, some areas of London. There's government incentives where you can get up to 30% off our product. And we also have a 100% tax relief as well. So for how much you spend on our equipment, you can reclaim back 100% of that tax through a scheme called the ETL. So this is a government program. And again, that all goes into the return on investment. So from the installations we've done so far, the return on investment averages out around about 24 months. And as far as I know, there's not another heating system which can be installed which can achieve that. And also the incentives are only going to get greater the further we go down this net zero road, because that's the only way the government's going to get anybody to change is, they've got to incentivise companies to change, basically, because the deciding factor on anything is always comes down to cost. Unfortunately, it could be amazing for the world and reduce 100% of emissions, but if it's out of the reach of these customers, then they're not going to buy it. So government definitely has to play a role in keeping the incentives coming, and I believe they will. I think they made a statement last month about a £3 trillion spend per year till 2050 needs to happen to get us there. But we sort of take care of all that legwork of looking for these grants for our customers. So yeah.
Oh, really? That's obviously very, very good to know.
If people are getting in touch and they want to know what is the cost saving, what's the return on investment, how much can we get from the government, we'll sort of take care of all of that side, all that paperwork side. Yeah, trying to make it as smooth and as seamless as possible.
Constructive Voices.
That's Tom McGee, founder of X-Heat, and you can find out more about them and what they do at xheat.co.uk or find them on social media. And that's all for this episode of Constructive Voices. Please take a moment to share it with others who may find it interesting. Follow or subscribe to get the latest episodes automatically on your favourite podcast app, and rate and review the podcast if you can. You can also listen to the latest episode by saying, Alexa, play Constructive Voices podcast.
Here's Constructive Voices. Here's the latest episode.
And on our website, where there's lots more information too. That's constructive-voices.com. Don't forget the dash. Until next time, thanks for listening. You're really helping us build something.